all attendants. If you have any questions, please write in the question and answer bar section. At the end of the presentation, we will discuss it, and Niall Phillips will try to answer all the questions you have. So this is the second presentation for our virtual SOUG Day, and I hope I will pronounce it correctly. Niall, sorry. Niall Phillips will talk about the Oracle text, a powerful tool for Oracle developers in English, not French.
Je peux le faire en français aussi, mais...
Mais oui, mais moi, non. Un petit peu. So, Niall, it's yours. Please start. Thank you.
Okay. Good morning. Thank you all for coming to my presentation. So today I'm going to talk about Oracle text. So let me just do the obligatory, tell you a little bit about me. My name's Niall Phillips. I'm the owner of a company called Acre, also co-owner of a company called Stevenson Associates, both based in Geneva. I'm an Oracle ace. I've been using the Oracle database for over 30 years. Doesn't make me feel any younger. And I've been developing web applications using Oracle since 1995, since they first brought out their first ever web toolkit. I've been using Apex since before it was called Apex, since it used to be called HTMLDB, and I organized the Swiss Apex meetup group. Here you have my Twitter and my email if you need to contact me. So, first, also, thank you very much to all the organizers and sponsors of this SOUG Day. It's great that we're able to do this despite the current situation. Just a bit about the Oracle ACE program. The ACE program is a program with various different tiers of membership, and it's basically people who give back to the community, the Oracle community. If you know someone you think should be nominated as an ACE, you can nominate them yourself via the ACE nomination link that's down there. Okay, let's talk about Oracle text. So, Oracle text was first released with Oracle 8, and it was called Context at the time. And you'll still see some traces of that today, because the schema name that you see that owns all the Oracle text objects and procedures is called CTX-sys. So it was renamed to Oracle Intermediate Text with Oracle 8i. And finally, with Oracle 9i, they renamed it to Oracle Text, which is the name it still has today. So, for once, an Oracle product has managed to keep its name for almost 20 years now. That's good. It's an integral part of all the Oracle databases, including, and it always has been, including the Express Edition and the Autonomous database. And as you'll see, it's just there. It's out of the box. Everything is there for you. Why would we want to search using Oracle text? Well, it's really, really fast. And it's very easy to start using. Hopefully at the end of this presentation, you'll have all the information you need to go out and start using Oracle text. You just create an index and search. We can index different data types. We can index varchars, we can index XML, JSON, CLOBs, and BLOBs like .doc documents or PDFs and so on. For querying, we're going to use the contains clause. Much more about that in a moment. We can have complex Boolean type logic, and there's a lot more features that many of which I'm not even going to touch on today. So what do people do? Your typical developer who doesn't know that they have Oracle text, or somebody who's new to Oracle, or someone who just treating an Oracle database like a database without using the Oracle features. They'll do something like saying, I'm looking for something where my text is like, and I'm looking for the word dog, so I'm going to put a percentage in front of it and a percentage after it, and look for the word dog. If I'm being, this is a case-sensitive search, obviously, so if I was looking for all the different ways of writing dog, I could do something like this, or I could put a lower around my column and compare it to the lower of dog. Now, this isn't great for a few reasons. One is, as soon as you've put a function like this around your column, unless you've created a function-based index, this is going to be slow. It's not going to be an index search. If you're doing a like search with a percentage in front of your like, once again, it's not going to use the index. So what do? So we're going to create an Oracle text index. Now, today I'm going to use, one of the tables I'm going to use for my demo is a table of judgments. This is from an openly available database of judgments in an international tribunal. So I've created a table. The column that I'm interested in mostly is the decision, which is a 4,000 byte column in that. So to create an index is very simple. We say create index, then we give the index a name. On, we say which table and which column we're going to index. Now, this is what's different. Index type is ctx_sys.context. So here I'm telling it, this is an Oracle text index. So here's a real example. Create an index on a table. The index is called text_judgments $1 on a table called judgments on the column decision _en. Index type ctx_sys.context. So that took about, this was on a very, very, very tiny database on a tiny little virtual machine. And it took about 9 seconds. So now that we have the index, we want to search using this index. So the syntax in general is select star from, okay, nothing new there, where contains, now, so in the column I want to search and the text that wants to be searched greater than 0. So this pseudo function contains should bring me back a value greater than 0. So if I'm looking in judgments for a decision that contains the word assessment, I select count and I'll get back some results. So let's have a look at some basic searches. Here I'm using the autonomous database. Oops, excuse me. Need to come out of full screen mode in order to switch screen. Okay, I'm quickly going to refresh, make sure I haven't been logged out in the meantime. Okay. So here we are on a small Apex application I've written to do a search. So let's do the simple search I told you about earlier, just using a like. So if I did that, I would just get a few little results. So let's do a little bit of a more complex search. So here I'm going to type in the word assessment. And here we can see I've got back 5 results. And interestingly enough, you notice that the word assessment here in uppercase, so it's completely case insensitive. Here I have the word assessment in lowercase. So these are the 5 judgments which have the word assessment in the text of the decision. So what was the SQL? The SQL was select star from judgments, where contains decision, and search text, which is the text that I've entered in this field. So this is what has just been executed. Right, back to my PowerPoint. So we have the concept of scores. Now, inside of a query, some things may be more relevant than others. Now, Oracle, what it does is it provides us the possibility of scoring a result. Now, the higher the score is, the higher the relevance is. Scores always have a range from 1 to 100. And very important, because I've seen people misuse this. Scores have no meaning outside of their own query. So imagine if you have subqueries, doing Oracle text queries and so on, you cannot compare the score of one subquery with the score of another subquery, because they're different queries and the scores cannot be, they're not comparable. So how does score work? So you've noticed for the pseudo function, we're saying select score. And here there's a little 1 in brackets afterwards. I'll explain that in a second. Second thing, from my table where contains the text. And here I've added another parameter, which again is a 1 here. Now what's important here is that the number you put here is the same as the number you put here. This is because if you have multiple contains clauses in your query, you want to be able to distinguish which one you're scoring. But having said that, I also would say that if you have multiple contains clauses in your query, you're probably doing something wrong. But that's another issue. So I'm going to go back to my demo and we just do a quick one with score. So we do the same word, assessment. And we see that one of them, this first one has a score of 23. Then the next 4 have scores of 12. Why? Because Oracle has decided that the word assessment is more important. Maybe it's because it's used multiple times, maybe because it's earlier in the paragraph, but it's decided in its wisdom that the word assessment is more relevant in this text than it is in the others. So that is score. It's got its limitations, but for a quick and simple thing that's available out of the box, it's not that. So we talk a little bit about the operators. So as I said earlier, there's some Boolean type operators. So as you'd expect, we can have an and, for example, cats and dogs. And each of these operators has a symbol which we can use. So for and, I can use an ampersand. For or, I can use a vertical bar. For not, I can use a tilde. And for accum, which is probably the only one that needs an explanation, I'll use a comma. So in accum, when you're putting in multiple search terms, it'll look for at least one occurrence of one of the query terms. So as you see here, if I put in dogs, cats, puppies, it's enough that one of these terms be there. Now, if you don't specify your operator, the accum is what will be used by default. So, typical example, if I'm looking for the word assessment and the word damages, I can say assessment and damages, or I can say assessment ampersand damages. Same thing with or, using the virtual bar. Same thing with not, using the tilde. And the same thing with accumulative, using the comma. There are other operators out there, quite a few actually. There's equivalence, near. I'm looking for a word that's near another word. Minus, stem, if I'm looking for a word stem. Sound X, which works for some languages. It doesn't work for all languages. You know, does this word sound like this other word? And fuzzy searching, which is actually quite nice and powerful. So go back to my little application. I'm going to do a little bit of fuzzy searching. So I'm going to look for the word damages. What do I have? I have 659 results. So I'm going to spell it wrong. I'm going to put 2 G's into damages. I've still got 659 results. Okay, let's try a J. Damages. I've still got them. What happens if I make that an N? Damages. Okay, it still thinks it knows what I'm talking about. I lost about 5 results there. And finally, I make it completely unrecognizable by saying danagex. I've got down to no results. Make it damagex. I'm back again. So this is fuzzy searching. It's very good if you're searching for people's names, which are often spelt in ways that are not intuitive, and other types of things. When you want to be a little bit forgiving to the user for the text that they're entering. So then we have terms that, oops, I forgot to turn off my alerts. There we have terms about, whoops, let me start again. Sometimes the words, which are the operator words, are part of a term that we're searching for. So for example, if I'm searching for Africa and the Near East, the word near is also an operator. So we need to escape the word near in order to have Near East look like a correct thing. I need just a few seconds from you here because I've lost my mouse. Oops, this is embarrassing. Ah, there it is. Okay. Sometimes when I switch to full screen, my mouse disappears. I don't know why. Okay, so as I was saying, near is an operator, and we need to escape that by putting, if we want to say looking for Near East, we need to put these curly brackets around it. So this is saying I'm looking for an expression which is exactly Near East. So what looks like an easy search has suddenly become quite a complex one. I need to say Africa with curly brackets, an ampersand, and Near East. That's not something you can ask your users to do. Users aren't ready for this. So it'll be quite complex to get this, this up and running, and we need some sort of pre-processing. Users want, well, one thing they definitely don't want is to know anything about the Oracle text grammar. What they want is everything to be like Google. If I could tell you how many times people have said to me, oh, I want it to be like Google. On days when I want to explain to them how difficult this is, I say, well, give me the budget of Google and I'll make it just like Google. Anyway. So I've been doing Oracle text for a long time, since about 2001, and I had built up this library of replacements that I would make. So I would go through people's text and sanitize it by removing characters I didn't want, by replacing characters by other characters, etc., etc. It used to grow every year, and it was about 100 lines long. And when I was researching to make this this talk last year, I came across something, a package called Parser, which is provided by Roger Ford, who is the Oracle Text product manager. Now, this parser does everything that I had tried to do here in the past, just does it all for me. And it just saves so much time. So I threw out my 15 years of work and have now replaced it by calling this parser package. So in the parser package, I'm using a package name and a function called simple search, which you give it a search term like ad hoc committee, and you put the quotations here, just like in Google, and it will return you what Oracle Text needs in order to make an accurate search. So for example, if I type in assessment damages, that becomes by default the cumulative operator. So it's assessment, comma, damages. If I type in plus assessment plus damages, it becomes assessment, ampersand damages, and damages. If I say I want plus assessment minus damages, so I want everything that has the word assessment but does not have the word damages, it puts the tilde, which means not, in here. But the great thing is that although we know this, we don't need to know it anymore, because we have this great package called Parser that's just there for us, downloadable, and the links are in this presentation. So we go to pre-processing. So just here we have the results, and here we can see I put in some little debug type statements. So we can see this is what the user entered. This is what was sent as the processing. So you can see that even the word and was unnecessary there. So I say assessment damages. We'll have a look. We see we just got assessment damages. If I say assessment minus damages, see I've got much less results, and here we can see that the package, this parser package provided by Oracle, will put the ampersand, the tilde in there for me. The fuzzy search I showed you earlier, this is how it works. So we use an operator called fuzzy, in which case we say the search term, we give a score, which is how similar it will be. Basically, it decides how wide the search is going to be. There is a maximum number of results that we want, the maximum number of terms that it will expand to. And this thing weight or no weight, which we can usually ignore. So if I was searching for the word immunity, I could say where contains search column and fuzzy immunity. That will find various different spellings or misspellings of immunity for me. So just showing you that in the demo, so that's it. The next thing is structured data. I mentioned earlier that we can index a lot of different types of data in Oracle Text. So we can index XML data, JSON data, CLOBs, BLOBs, and much more. So here I have a table of publications, and there are two columns in there, one called XML content, the other called JSON content, which contains the content of these publications. These are publications international of different international standards. So this is a typical XML content. So we can see things like it's got titles, it's got types, it's got various different tags, and we can see the data that's within those tags. So first thing you need to do is create an index on this. Create index, index name, on publications table name, the column we're on. Index type, like we saw before, is ctxsys.context. And here's something new. It's saying parameters, data store, we're just letting some things default here. The important part here is the section group. So I'm saying section group, auto section group. Now, what this means is that we're telling it it's a structured document, and it's going to search for the structure using the auto section group. I can use the auto section group because it understands HTML and it understands XML. So it'll automatically make the sections. Here, this was a table of 33,000 rows, again on my incredibly slow virtual machine on which I did this. It took about 29 seconds to make that. I also made an index on the JSON content. And in this case, I had to tell it that it was a JSON section group. And that case, it also took a bit longer. It took 71 seconds for the 33,000 rows. So when we're searching the structured data, for example, I want to know all the publications that contain something. I can say, give me the publication ID, give me the XML content as a CLOB, and I'm using the contains just like before. So this, the actual search query is not very different to the to what we were used to. But now this is the really nice part. We can do tag-aware searching. So we use an operator called within. So we can say, I'm looking for everything that has the word immunity inside of the title tag. Now this starts getting very interesting because it means that we can do a structured search of our XML document. We could do the same thing with the JSON. I'm using more JSON style syntax. So let me demo this for you. So, okay, oops, okay. We're going to search for immunity. And we can see I have 526 results. And, well, here's the word immunity in the first one. And the rest of the XML, you're not really interested in looking at screens and screens of XML, but you can be sure I'm going to find the word immunity in each of these. So let's search in a tag-aware way. So, well, first of all, let's search for the word electromagnetic. I get 938 results. But let's say I just want this within the title. Now I have 684 results. Sure enough, there's a title with electromagnetic inside it. This immunity within the title. I got 415 results. Notice, by the way, how fast this is. And this is very fast. These are quite big documents. So over here, this time the immunity was over there somewhere. Yeah, immunity. So we can search XML. Now this leads us to something else. Now, one problem, I mentioned earlier that if you have multiple contains clauses, you're probably doing something wrong. I've seen many cases where somebody takes a table. Let's say it's a table that's got a title, then it's got a description, then it's got a short description, then it's got a long description, then it's got some other field with the author's name and another field with the name of the institution that the author works for, and so on. So I've seen many cases where people will index each one of these columns and put in 4 or 5 contains clauses. This is a bad idea because you really mess up the optimizer and it doesn't know which index to give priority to anymore. So one solution I use to this is using XMLGen, which is a package provided by Oracle. So if I select dbms xmlgen.xml type using the function xml type and pass it a query, for example, I have a query for a table called load videos, and it will bring me back XML content. So by doing this query here, I would get the XML content of this. By default, it uses row set and row tags for the row set for the entire set of results and row for each row. That can be customized. So my solution to making turning a multi-field view or table, it doesn't really matter, into a very easily searchable structured document is, for example, I create a table called My Videos, which picks up the ID from the other table. And there I'm selecting, I want the XML for each entry where the ID is equal to the ID from here as an XML. So this will bring me back a table of XML with 2 columns. One column which will be an ID and the second column which will be an XML type column called XML content. This is what the table will look like. So I've taken my 40-50 column input and turned it into a 2-column table, which of course now I can index the XML content using auto section group, just like I did in the previous XML. And I can now search my table saying, and I want anything which contains, for example, the word village in the XML content. And being XML, of course, and using the tag sensitive indexing I mentioned to you earlier, I could also say I want everything from my videos table where the ID contains the word French, contains the word French within a tag called linguistic version. So I've managed to take multiple fields, put them into a single field, index that, and use that for all my searching. And that is very efficient. And I've said this multiple times before, I'll say it again, very fast. Now, we can also index blob columns. So back in my judgment database, we also have the official PDF files for each judgment. Now, these files are usually about 20 to 30 pages long, and they're held in a table that has a column called file content, which holds the BLOB that holds the PDF. How do I index this? Exactly the same way I did my first index. I don't have to think about anything more than just say index type is CTX index.context. In this case, okay, like I said, they're 20 to 30 page PDFs. I had about 4,000 rows. It took me 355 seconds on my extremely slow virtual machine. So still not bad. Also, these indexes do not need to be recreated every time there's updates. Only the changed rows need to be recreated. So if I'm searching, I search the same way as before. I just say where contains on the text that I'm searching for. Now, I may want to present these in a nice way. So they said, there's some nice little packages Oracle Text gives you. One of them is called Snippet, which will tell you, like I say, these are 20 or 30 pages. Somebody is searching for a word. Where did he find that word? We need to see a little bit of context in order to know, is it the right result or not? I don't need to search, I don't want to search the 30 pages each time. So this snippet function will let you see where it was. It'll put bold around the term and will separate different terms with 3 dots. So let's have a quick look at that. So here, searching PDFs, let me just clear everything that I was doing when I was rehearsing earlier. So here, if I'm searching, oh, why change? Let's search for the word immunity. You can see it's brought back a whole lot of things with immunity on it. Now the SQL itself, in this case, is a little bit more. I've put a tiny bit of HTML in there. We'll see why in a little moment. But basically, I'm just putting in a link and the H4 for the header. And here I'm using the snippet to show what I have found. I'm passing in the index, the row ID, and the text, the process text. So again, we can see here, this is my H4 heading with the link I put in. And here we can see the word immunity coming up. I'm going to come back to that now in a second. So basically what I've done is I've added in a little bit of HTML. I know this isn't the world's best practice, but it's just to illustrate the point here. I've added in the snippet saying which index I want to use. I'm passing the row ID and I'm saying what the text was. It'll find in the document where the result was. There's also a PL SQL way of using snippets that will return an array to you. So depending on your use case, you may want to use this as well. So go back to my, my demo. So here we see immunity. So we see it in context. We see 2-way is immunity, driver's immunity. So I say, okay, well, that actually isn't what I wanted. I wanted diplomatic immunity. So here you see I'm getting diplomatic immunity, but I'm also just getting immunity. Yeah, so that's not really what I want either. So I'll go back to my text processing, Google-like search. I say, no, I want the exact expression, diplomatic immunity. And now I have all the judgments which have the 2 words diplomatic immunity as an expression. I pick one at random, I click, and this is the PDFs of that judgment. So being served directly out of the database, of course. So how am I doing on time? Okay, let's. So there are things called lexers in Oracle Text. By default, so you can just use the basic lexer, but there are Others, including the multi-lexer and word lexer, which are good when you're doing non-Latin languages. If you want to create a preference, you can say, okay, I'm making a lexer, which in this case was called SOUG lexer, based on the basic lexer. I can also create different language lexers. For example, I make an English lexer of language English, French lexer, language French, and a global lexer to which I add English and French as sublexers. So you can have multilingual lexers, and you can have multi-language ones. Most of the applications I've worked on have been trilingual, and we've never had any issues with this. Another interesting thing are stop lists. Every language has its own words that you want to ignore when you're doing text searching. So for example, the word the word also, there, that, this, and so on are all words that we just want to ignore. So we can make our own stop lists. So for example, if I want to make a stop list there, make it, and I want to base it on basic stop list. This is a little PL SQL call. I can add stop words to the stop list and then create an index using that stop list. So I have a quick application that I've written to manage the stop lists. And I've lost my mouse once again. So for example, I made a stop list called SOUG Day Stop. I can add a new stop word. All this is doing in the background is making a so if I've added in Thursday as a stop word, this word will now be ignored. So let's do a demo. So I'll search for immunity once again. Oh, sorry, wrong table. I'll search for assessment. I got 5 back with assessment. Assessment damages. I got 2 back. Assessment or damages. 1 back. Oh, sorry. Excuse me. Assessment and manner. I've only got 1. So now I'm going to go back to the other page and I'm going to add the word manner in as a stop word. So, manner. Add this stop word. I have to rebuild the index. Oh no, this is the demo effect. Okay, I'm going to skip this. We're running low on time. What I was going to show you was that the that the stop list would be applied and that the query would start ignoring the words that we were searching on. I'm not quite sure what went on there, what went wrong, but I'll be able to check that afterwards. Okay, Oracle text can also index text that's outside of the database in external data stores. So you can index using the file data store for OS files, URL data stores if you wanted to go and look at a URL to find what's there and index that. or possibly the most powerful of all, user data store, which is where you provided a PL/SQL procedure where you can interpret, transform what you want, what you're indexing, and present it in such a way that, in a transformed way, to Oracle text for indexing. Just a word on synchronizing indexes. There's various ways of synchronizing indexes. One is where you're doing it manually. Basically, you call this procedure ctxddl.syncIndex, index name, and it'll synchronize the index. You could make a little loop that would synchronize all your CTX type indexes. So those are manual ways. When you create the index, you can say parameters sync on commit. This will synchronize every time a transaction to that table is committed. And you can also ask for it to be synchronized on regular intervals. For example, every hour here, every 24th of a day. Which one of these is the right one? It really depends on your use case. It's yes, I mean, just like as I said, it depends on your use case. Very often, sync on commit is just fine. But there are cases, for example, where you're doing large loads that maybe you don't want to make it to sync everything all at once. Or maybe you want to have some more control over when you're synchronizing. Up to you and your application. So for further reading, there's the excellent Application Developers Guide. I mean, hats off to Oracle. They've written some really good documentation here. And where I got the parser package from is the blog from Roger Ford, who is the product manager for Oracle Text. And there's a lot of very interesting articles on that blog. So questions, let me have a look and see what we got.
Yes, there are some questions. Did you see them, or should I ask them?
I'm looking for them. Hang on. There's Zoom. Okay, Zoom is here, but I'm not seeing. No, I'm not seeing them. No.
Okay. Then I will ask the first question. It's from Hachemi. I hope I pronounced it correctly. He asked, does Fuzzy support Chinese or Arabic?
That's a very good question. And I don't want to, I think it possibly does. I'd say it's more likely with Arabic than Chinese, but without testing, I couldn't really answer that directly. I have tested it on quite a number of European languages and on Cyrillic languages too. But I haven't tested it on Arabic or any of the Asian alphabet languages.
He also
asked, so just to add to that, but Chinese and Arabic are both fully supported languages in Oracle Text.
Oh, okay. Thank you. He also asked, did the search in PDF include OCR?
No. It's searching text, not pictures. Yeah.
Okay. And should we update the index text after update the table?
It depends. That's what I treated just at the end there. It depends on how you defined your index. If once you've updated the table, you could manually update. If you had defined the index as a sync on commit, it would automatically update as soon as you've committed. And if it was a regular interval, it would update whenever that interval arrives.
Did the word order matter in search?
No, it doesn't.
Okay, and the last question is there a way to estimate the text index size?
How long is a piece of how long is a piece of string? It's basically the column that you're indexing is going to get broken down into tokens. And actually, let me just is my screen still being shared? Yeah.
Yes.
Let me here you can see some of the tables there. So, for example, on my judgments table, we can see that Oracle has actually created, when I created the index, it's created 5 tables in the database, which are breakdowns of the tokens and other things that it needs in order to be able to search. They always begin with D or dollar for some reason I don't remember. And so these are, when you're talking about the size of the index, it's the size of these generated tables that we're really talking about. And they will depend on, literally on how many tokens it's indexing.
Okay. So, is there any more questions? I will ask the attendees. I think you answered all
Okay.
questions. And he says thank you for answering.
Yeah.
So I think he's satisfied with the answers. Thank you very much for the presentation. We will stop the recording and then upload it for the other who couldn't see your presentation on this SOUG Day event. So thank you very much and stay safe and stay healthy.
Thank you. And thank you all for having the patience to listen to me. Okay. Bye.
Bye everyone. See you next session. Bye.
Bye.